Dear students, today we will discuss about modular implementation. So suppose a software has been built and that software contains 100,000 line of code. So if someone want to edit that software, want to update something and want to make any change to that software, then looking at that software, if that has not been written in a structured way, then it is very difficult to understand that what you have performed at what line of code. So even if you have written that code, even then it is very difficult to again understand that why you have written this code, why have you written this line of code, and what was its purpose. So one of the way is that we should also document, but there is another important thing, that we should build the softwares in a modular way. So what does it mean, the modular way? Modular way means that we should divide the whole software into small chunks. So for example, if you want to build a software for virtual university, and that software will track the students admissions, students examination, and for example students attendance. So these three are the main modules. These three can be considered as the main modules on which you should develop separately the software. So which means there should be a module of students admission, there should be a module of students examination. So if you want to change anything in the procedures of student admission, then you should open only this part of the code and you should try to make changes. And if you want to make changes or added in the student examination procedures, then you should open this code which contains the information, the source code or the software lines related to students examination. So we will build, or we normally in industry build things in modules, and module wise implementation, division of software into manageable units. So even if you think that this student examination is a bigger module and it can further be divided into sub modules, so please do it like that, so that you have very small, very focused modules which can be treated as an independent entry as much as possible, and then that entity can interact with the whole system, and if there is any change, you just consult that particular entity. So what are modules? We have discussed different kind of programming paradigms. For example, in imperative programming paradigm, functions are those modules. So modules can be implemented using functions. In object-oriented paradigm, the objects can be considered as the modules as for implementation. So let's have an example of imperative paradigm. So here, for example, we want to play tennis and there are two players. So this is a computer game and both players have some characteristics, and based on those characteristics they serve the service, and then that ball goes to the next player's territory, and then that player return the ball, and if it is not returned, then the score of player A is counted. So if we look into this example, we could have these four modules. So one is called serve. So this serve module have speed, direction, players characteristics, and based on all of these things, the serve module will service the ball to the next court of the player 2. And then there is another module known as compute path. So this compute path will get the information from serve like direction, player characteristics and speed, and it will see that whether the ball should hit the net or should go onto the other side of the net, and where it should bounce, etc. Then there is another module known as return. Will it be returned or not, and what would be the next speed and the direction of the ball. and if there is any score given to player 1 or player 2, then there is a function or module known as update score, which will update the score of a player. So this means that we have divided the problem of playing tennis into 4 modules possibly. So we will have one other module which is known as control game, which will coordinate with all of the modules which we have discussed. So this means at first the control module, a control game module will call the serve module and it will service, and then there is a return module. Compute path will be calculated after serve and return, and then the update score will be calculated. So if we summarize today's module, we have discussed that software should be divided into small chunks, small manageable units, and each of the unit is known as module. And we have discussed the examples of imperative paradigm, that how module can be invented, discovered. Next we will see that how these modules interact with each another and what is a good module.